Good morning, everyone. In the last lecture, we discussed how to find the solution to the linear programming problem graphically when we have a maximization of profit or maximization problem. Today, we will consider the graphical method to solve linear programming problem, especially by taking the example of minimization problem, or we can say that it is minimization of cost. See, first we are going to consider one problem that we are going to convert in the form of mathematical format. See, the problem that is given here, a diet for the sick person must contain at least 4000 units of vitamin, 50 units of minerals and 1400 calories. Two food items, that is food X and food Y, are available at the cost of rupees 4 rupees and 3 per unit respectively. And if 1 unit of X, that is food X, contain 200 units of vitamin, 1 units of minerals and 40 calories, and similarly 1 unit of commodity Y, that means food Y, contain 100 units of vitamin, 2 units of minerals and 40 calories. See here, what is our question? Formulate this problem as a linear programming problem, and then we want to solve this particular given linear programming problem by using the graphical method to find the combination of food to be used to have a least cost. See, I hope you understood the question. See, from the given question, what do we want to find out? The combination of food item, that is combination of X and Y, so as to minimize the cost. That means least cost. So here, first we are converting here what are the various information are given in the problem. See, the food X and Y which are available. So two commodities, so two decision variable are here, that is food X and food Y. Similarly, this food X and Y which contain the vitamin, minerals and calories. So these three things are contained in the food X and Y. So I am going to write the vitamin, mineral and calories. So how much unit of vitamin, minerals and calories contained in the food X and Y, which is already given here. See, if 1 unit of food X contain 200 units of vitamin, 1 units of minerals and 40 calories. So that this information we are going to represent here, the food X which contain 200 units of vitamin. So I am going to write here, it is 200 units of vitamin, 1 units of mineral and 40 calories. Similarly, from the given problem, 1 unit of food Y which contain 100 units of vitamins, 2 units of minerals and 40 calories. So I am going to write here the food Y which contain 100 units of vitamin, 2 units of minerals and 40 calories. Now, in the given question, see, some more information are given, that is a diet for the sick person must contain at least. So for a sick person, a minimum of at least 4000 units of vitamin, 50 units of minerals and 1400 units of calories are required. So this is minimum requirement. So our problem, this is a constraint and it will be minimum of 4000 unit of vitamin. So it will be greater than or equal to, as against in the profit maximization problem where we said that the sign will be, the constraint sign will be less than or equal to, but here it will be greater than or equal to because it is a minimum requirement. So minimum it should be 4000 and it may be greater than 4000 as well. So this information I am going to write here. See, minimum requirement of vitamin, this is 4000, mineral it is 50 and calories which is 1400. Then again from the given problem, some more information, that is food X and Y are available at a cost of 4 rupees and 3 rupees respectively. That means the cost of food X is equal to rupee 4 and the cost of food Y is equal to 3 rupees. So I am going to write in this particular table, see here, the cost of food X is equal to 4 and the cost of food Y per unit which is equal to 3. See, now we have a table I am going to represent in a tabular format. So in this particular tabular format, what we want to find out, I am going to take it separately. See here, in the given problem, what are the information given? We want to find out the combination of foods, that is combination of food X and Y, which used to have a least cost. See here, the question is giving the hint regarding which type of objective function we have. Of course, we want to find out this least cost combination of food X and Y, and he want to minimize the cost. Of course, if this is least cost, which means that he wants to minimize the cost, so that what will be the combination of X and Y. So here I am going to make some various steps, especially for formulation of linear programming problem. First, we have to identify what are the decision variables. See, what are the various decision variables here? The decision variables are food X and food Y. So we have a two decision variable X and Y. Then after that, we have to identify what is our objective function and we have to formulate our objective function. Then after that, we have to find out what are the various constraints which are given in our problem. Then we will go for non-negativity of the variables. So for here, first we are going to identify, as we are already identified what are the various decision variable, that is food X and food Y. Then we are going to identify the objective function. Of course, we are already said that it is related to the least cost combination of food X and Y. So it is minimization of cost. So here the poor patient or the poor person, he wants to minimize the cost. So here the minimizing cost, see, the cost of X is equal to 4 and the cost of Y is equal to 3. So I am going to frame here the objective function, that is minimization of cost. I am denoting the cost in terms of C, which is equal to 4 into X, that is 4X plus 3Y. So cost is equal to 4X plus 3Y. So this is our objective function. Here the objective function is minimization of cost and we want to minimize C, which is equal to 4X plus 3Y. See, after identifying the objective function, the next step, we want to identify what are our constraints. See, what are our constraints? Vitamin, mineral and calories are our constraint, and where we have a minimum requirement. So this is the constraint, that is he have a minimum requirement of 4000 vitamins, 50 minerals and 1400 calories. So by using this particular information, we are going to frame, constraint. What are the various constraints which is subjected to the given objective? See, 200x plus, in the case of vitamin, 200x and 100y. That means in the food X is containing 200 vitamins and 100 vitamins in the commodity Y or food Y. So here we are going to construct the constraint, that is 200x plus 100y, which is greater than or equal to 4000. This is one of the most important information, that is it is greater than or equal to. As in the previous example, we said that it was less than or equal to because the maximum available resources was given. Here it is minimum requirement is given. So minimum it is, that is equal to 4000 or greater than 4000. So we are using this sign symbol here, it is greater than or equal to 4000 vitamin. Similarly, the food X contain 1 unit mineral, then food Y contain 2 units of minerals, and total minimum requirement of the minerals is 50. So our second constraint will become, see, 1 into X, which is equal to X plus 2Y, which is greater than or equal to 50. And similarly, the third restriction, that is regarding the calories. Food X containing 40 calories, food Y containing 40 calories. So here, we are going to frame a constraint, the third constraint, that is 40x plus 40y, which is greater than or equal to 1400. See, we have a 3 constraint here. Of course, we have a 3 constrained vitamins, minerals and calories are here. And of course, we have a 2 decision variable, that is x and y. So here we are assuming that non-negativity of the variable, that is x is greater than equal to 0 and y is also greater than or equal to 0. See, this is the formulation of linear programming problem. I am going to write it separately in the form of mathematical formulation of given problem in the mathematical model, that is minimize c is equal to 4x plus 3y subjected to the constraint, that is 200x plus 100y which is greater than equal to 4000, x plus 2y which is greater than equal to 50, then 40x plus 40y which is greater than equal to 1400. So we have, of course, x is greater than equal to 0 and y is also greater than equal to 0. See now, after the formulation of linear programming problem in the mathematical format as given here, we are going to sketch this particular constraints in the graph. How we are going to make? See, first we are going to construct a graph. See, we have a x axis, we are going to take the food x, and on the y axis we are going to take the food y. And then, we want to find out what are the various coordinate points of the constraint. For that, we are considering the first constraint, that is constraint number 1, which is equal to, 200x plus 100y which is greater than or equal to 4000. Now I am going to change this particular greater than or equal to sign into the equality sign so that we can solve this particular equation. So it will become, see, 200x plus 100y which is equal to 4000. Now let us assuming that the y is equal to 0, we are going to solve this particular equation for x by substituting y is equal to 0. So it will become, see, 200x plus 100 into y is equal to 0 which is 4000. So it will become 0. Then what is remaining here? It is 200x is equal to 4000. Dividing the both side of the equation by using 200, we can say that x is equal to 4000 divided by 200 which is equal to 20. So when the value of y is equal to 0, then x is equal to 20. Similarly, by assuming the x is equal to 0, we want to find out the value of y. By considering the constraint number 1, see, the constraint number 1 we are equated with, see, here we are converted the inequality sign into the equality sign. Similarly, we are going to assume that the value of x is equal to 0, as against here the value of y was 0. Now we are assuming that x is equal to 0, then we are going to find the value of y by using the constraint number 1 by changing the inequality sign into the equality sign. So the constraint number 1 which is equal to 200x plus 100y which is equal to 4000. By assuming x is equal to 0, it is 200 into 0 plus 100y which is equal to 4000. Then this term will become 0. Then 100y is equal to 4000. Dividing the both side of the equation by using 100, then it will become y is equal to 4000 divided by 100 which is 40. So when x is equal to 0, y will become 40. Now we want to plot these coordinate points on the given graph. See, here the scale points will be, lies between, 20, 40. So we are considering here, it is starting from 0, 10, 20, 30, 40, 50 in the both axes. And then we are going to mark here, see 0, 20, 0, which will be here. See, it is 20, 0. That means when y is equal to 0, then x is equal to 20. It will become here. Similarly, here 0, when x is equal to 0, then the value of y is equal to 40. And these 2 points I am going to connect with a line, and this is the red line which is showing that this is constraint number 1, that is 200x plus 100y which is equal to 4000. So this is representing, this particular line is representing for the constraint number 1. Now similarly, we are going to consider the constraint number 2, that is x plus 2y is greater than equal to 50. Now this greater than equal to sign, I am going to convert into the equality sign so that we can solve this particular equation. So that is x plus 2y is equal to 50. Assuming that y is equal to 0, we are going to find out the value of x. So it will become, see, x plus 2 into 0, which is equal to 50. So 2 into 0, this term will become 0. So x is equal to 50. So we can say that when y is equal to 0, then x is equal to 50. Similarly, by assuming x is equal to 0, we can find the value of y as well. Substituting x is equal to 0 on the given constraint, then it will become 0 plus 2y, which is equal to 50. We can say that 2y is equal to 50. Dividing the both side of the equation by using 2, then y is equal to 50 divided by 2, which is 25. So when x is equal to 0, then the value of y is equal to 25. So we have a 2 coordinate points here regarding the constraint number 2. So we are going to plot these coordinate points on the given graph. So it will become, see, 0, when x is equal to 0, then y is equal to 25. Similarly, when y is equal to 0, then x is equal to 50. So it will be somewhere here. So I am going to join these 2 points here. See, the blue line which is joining the 25 on the y axis and 50 on the x axis. So this is showing the constraint number 2, that is x plus 2y, which is equal to 50. Now again we have one more constraint, that is constraint number 3. So we are again going to consider the constraint number 3, which is given, that is 40x plus 40y, which is greater than equal to 1400. So here this inequality sign, that is greater than or equal to sign, I am going to convert in the form of equality sign. So it will become 40x plus 40y, which is equal to 1400. Now by assuming value of y is equal to 0, then what is the value of x? X is equal to, y we are going to assume here it is 0, then it is 40x plus 40 into 0, which is equal to 1400. Then if you go for multiplying these two values, it will become 0. Then 40x is equal to 1400. Dividing the both side of the equation by using 40, then it will become, see, x is equal to 1400 divided by 40, which is equal to 35. So when y is equal to 0, then the x is equal to 35. This is the one of the coordinate of the given constraint. Similarly, we are going to assume that x is equal to 0, and we are going to find out the value of y from the given third constraint, that is 40x plus 40y is equal to 1400. So here, assuming x is equal to 0, substituting the value of x is equal to 0 on this given equation, then 40 into 0 plus 40 into y, which is equal to 1400. So if you go for multiplying this term will become 0, then 40y is equal to 1400. Dividing the both side of the equation by using 40, then y is equal to 1400 divided by 40, which is equal to 35. So when x is equal to 0, then value of y is equal to 35. Similarly here also, when y is equal to 0, x is equal to 35. Now we are going to plot these two coordinate points again on the graph, especially for representing the third constraint. So here when x is equal to 0, then see, it is representing here, when x is equal to 0, y is equal to 35. Somewhere here the point will be come out here. Similarly, when y is equal to 0, then x is equal to 35 somewhere here. So I am going to plot these 2 points here. Then it will become, see, this is the representing in terms of green line. This green line is representing for the third constraint, that is 40x plus 40y, which is equal to 1400. So we have a 3 constraints in the given linear programming problem, and all these constraints are represented by a particular line in the graph. Now, after the graphical representation, we have a 3 lines here which represent 3 constraints. The next step is to identify the feasible region. And you know what actually the feasible region is, which is the region which is bounded by the constraint line, or it is all the point inside the feasible region or on the boundary of the feasible region or at the corner of the feasible region that satisfy all the constraint. But here, the constraints are the greater than or equal to, as against in the previous problem it was less than or equal to. When it was less than equal to, our bounded area will be less than of that particular line, that is inside the particular line. But see, our constraint in this particular given problem, it is greater than or equal to 0, so that which is mainly happening in the case of a minimization of objective function. So hence the feasible region in this case should be outside. See, it is greater than or equal to, so that's why it will become outside this particular line. So I am showing here, I am going to shade the particular region that is representing the feasible region. See, this will be our feasible region. I am shaded area. See, this is the feasible region in the case of a minimization of problem, because our sign of the constraint were greater than or equal to. So in that way we can say that this is the feasible region. So this shaded region will be considered as the feasible region, and it is at any point outside this particular region, it is called feasible solution, and this give the value of x and y that satisfy all the constraints. So hence we can say that here in the feasible region we have the points like corner points of point A, point B, point C, and here the point D as well. So the region A, B, C, D will be the feasible region, or this is the corner of the feasible region, that is A, B, C and D. Now we want to find out the value of x and y on the feasible region or the various corner points, so that we can find out. See, at this particular point, we want to find out the optimal point out of these given feasible region. So feasible region are A, B, C and D. Out of this region, we will have a one region or one point which will give you an optimal solution out of the given feasible region. So feasible region, of course, as I have already told you, it will satisfy all your constraint, but all this feasible region cannot be an optimal solution. There will be only one point which will reach an optimal solution. In this case, it is a minimization problem, so which will give you a minimum of cost. So out of this particular given feasible region, what will be the minimum cost value? So that we want to find out. Accordingly, we will get an optimal solution. So optimal solution is always lies at one of the vertices or corner of the feasible region, that is A, B, C and D. So out of these four regions, see, we are going to consider here these four regions here, that is A, B and C. At point A, see, the value of x is equal to, it is 0, and value of y, see, it is 40. So I am writing here at point A, x is equal to 0 and y is equal to 40. Similarly, at point B, see, at this particular point, two line or two constraints are intersecting at this particular point, that is green line and the red line both are intersecting at point B. So that means here we have a two equation and these two equations are intersecting here, so that see, in order to find out the x value and y value at the given point B, we have to solve these two simultaneous equation, that is 200x plus 100y which is equal to 4000, then 40x plus 40y which is equal to 1400. These two equations we want to solve. We will solve it in the upcoming slides. So we want to solve the simultaneous equation at the point B. At the point C, again the similar situation. See, at the point C, we have a two line, that is blue line and the green line both are intersecting at point C. So at this particular point also we have a two constraint, that is two equation we have. One is green, that is 40x plus 40y which is equal to 1400, and another is blue line which is representing the constraint of x plus 2y is equal to 50. If you go for solving these two simultaneous equation, then it will give you the value of x and y at the point C, so that we also going to find out. Then the last point, that is point D. At this particular point D, what is the value of x? Value of x is equal to 50, and what is the value of y? Which is 0. So we can write it here, x is equal to 50 and the value of y is equal to 0. So now we are going to find out the value of x and y at point B and point C. So where we want to solve the simultaneous equation. So at point B, we said that these two equations will be considered. So I am going to consider these 2 points. See, in order to find out the value of x and y at point B, we have a 2 equation, that is one, it is 200x plus 100y, which is equal to 4000. And another one is equation number 2, that is 40x plus 40y, which is equal to 1400. Now we can use elimination method, or you can also use the substitution method as well, but here we are going to use the elimination method so that we can eliminate one of the variable, that is x or y, so that we will get the value of x and y accordingly. So here we are going to multiply equation number 2 into 5 so that the coefficient of the x can be equalized, so that we can eliminate the variable x. So here we are going to multiply the equation number 2 into 5, then it will become 40 into 5, which is equal to 200, 40 into 5, again it is 200y, then 1400 into 5, which is equal to 7000. So by considering these two, equation number 3 and equation number 1, then see 200x, 200x, we are going to subtract these two equations so that this x will be cancelled out. So 200x minus 200x, it will be cancelled out. Then 200y minus 100y, it will become 100y, which is equal to 7000 minus 4000, which is equal to 3000. So if you go for dividing the both side of the equation by using 100, then it will become, see, y is equal to 3000 divided by 100, which is equal to y. So when the value of y is equal to 30, then you can substitute this value of y is equal to 30 on any one of the equation here. So here I am going to substitute y is equal to 30 on the equation number 1. So equation number 1 here, it is 200x plus 100y, which is equal to 4000. So substituting y is equal to 30, so the equation will become 200x plus 100 into 30 is equal to 4000. If you go for simplifying it, then 100 into 30, it is 3000. So 200x plus 3000 is equal to 4000. Now we are going to subtract the 3000 from the both side of the equation so that it will become 4000 minus 3000. So it is 200x is equal to 1000. Dividing the both side of the equation again by using 200, then we can isolate the x, that is x is equal to 1000 divided by 200, which is equal to 5. So we received the values here at the point B by solving the simultaneous equation, that is these two equations we are solved so that our values of x and y, see, x is equal to 5 and y is equal to 30. Now I am going to write these two values instead of this particular equation here. It will become, see, x is equal to 5 and y is equal to 30. Now similarly at the point C also we have a simultaneous equation because the two lines are intersecting in the graph. So we want to find out the value of x and y by solving these two simultaneous equations. We have simultaneous equation, we have two unknown variables are here, x and y, so that we can find the value of x and y at the corner point C. So we are going to solve these two equations, that is equation number 1, that is we are assuming here it is 40x plus 40y, which is equal to 1400. Similarly the equation number 2, which is equal to x plus 2y, which is equal to 50. Now we are using here elimination method in order to solve this particular equation by multiplying equation number 2 into 40 so that we can eliminate the variable x. So if you go for multiplying the equation number 2 into 40, then the equation number 2 will become 40x plus 80y, which is equal to 50 into 40, which is equal to 2000. Now consider the equation number 1 and 3. See, we have the same coefficient of variable x, so that if you go for subtracting the equation number 1 from equation number 3, then we can remove the variable or eliminate the variable x here. So 40x minus 40x, which will be cancelled out. Then 80 minus 40y, it will become 40y, which is equal to 2000 minus 1400, which is equal to 600. So dividing the both side of the equation by using 40, then y is equal to 600 divided by 40, which is equal to 15. So the value of y is equal to 15. Now, once the value of y is estimated, then we can substitute the value of y in any one of the equation, either in the equation number 1 or equation number 2. So here we are going to substitute the value of y is equal to 15 on the equation number 1. Then it will become, see, 40x plus 40y, which is equal to 1400, that is equation number 1. Substituting y is equal to 15 here, then it is 40x plus 40y. Instead of y, we are substituting 15 here. If you go for simplifying it, then it is 40x plus 600, which is equal to 1400. So if you go for subtracting 600 from the both side of the equation, then it will become 40x is equal to 1400 minus 600, then it is equal to 800. So dividing the both side of the equation by using 40, then we can isolate the x, which is equal to 800 divided by 40, which is equal to 20. So we have the value of x, which is equal to 20, and value of y is equal to 15 on the point C, that is corner point or vertex at a point C. So instead of this particular equation, now I am going to substitute, that is value of x and y, that is x is equal to 20 and y is equal to 15. See here, we have a 4 corner points are here, and we have the corresponding to the each corner point, we have the value of x and y. See, all these are the feasible solution. See, out of these 4 points, there will be only one optimal solution are there. So accordingly, we want to find out that particular optimal solution from the given points of A, B, C, D and given value of x and y. So here I am going to substitute, the value of x and y in our objective function. So in order to find out the optimum point, minimum cost, our objective function is minimum cost, that is minimizing our cost, that is C, minimizing the cost from the given 4 corner points. So for that, we are going to substitute the value of x and y on the given objective function, that is minimization of cost, by substituting x and y on the given equation. So here, see, at the point A, x is equal to 0, y is equal to 40. So I am substituting here. C is equal to 4 into x is equal to 0 plus 3 into y is equal to 40. So if you go for solving it, then which is equal to 120. Similarly, at the point B, see, x is equal to 5 and y is equal to 30. Substituting here, then it will become 4 into 5 plus 3 into 30, which is equal to 110. Similarly, at the point C, x is equal to 20, y is equal to 15. Substituting these two values on the given objective function, see, 4 into 20 plus 3 into 15, which is 125. And the last point, that is point D, at this particular point, the value of x is equal to 50 and value of y is equal to 0. Substituting x and y on the objective function, C is equal to 4 into 50 plus 3 into 0, which is equal to 200. Now see here the value of objective function. It is 120, 110, 125 and 200. Out of these 4 feasible solution, see, one will be an optimal solution, or one point will be considered as an optimal solution, which will be, as in the earlier example, it was the maximum point because our objective was the maximization of profit. But here, our objective function is minimization of cost. So at that particular point of time, instead of searching for the higher value, we are going to consider the minimum value from the given objective values. So it is 110. See, 110 is considered as an optimal solution. So out of these, values, the lowest value, that is 110, this is considered as the optimal solution or the minimum cost. So in order to have the minimum cost with given requirement, that is the sick person want to consume, that is 5 unit of food X and 30 unit of food Y, so that his cost can be minimized and at the same time his requirement can also be fulfilled. So in this way we can find, so here we can say that the optimal solution, the minimum cost is 110, where how much quantity of food x and y shall be considered. See here, x is equal to 5, y is equal to 30. So x is number of units of food, x is equal to 5 units, and number of unit of food y, which is equal to 30. So this is the solution. So in this way, we can find the solution to the linear programming problem graphically when we have a minimization of the problem. So here the minimization problem was the minimization of cost. In the first example, we discussed the profit maximization problem, and in this particular problem, we considered the minimization problem. In the next lecture, we will consider how to find the solution to a linear programming problem graphically when we have a maximization problem. But the thing is that we have a mixed constraint. That means we will have a greater than or equal to, and at the same time we will have a less than or equal to. Both the constraint will be there. Then in that particular situation, how can we find the solution to a given linear programming problem by using the graphical method that we will consider in the next lecture. So we'll see in the next lecture. Thank you.